All right, so let's take a look at using the z-scores now. In the back of your book or on a site, like I just Googled z-score and found an online z-value chart. This is not going to make any sense to you at first, so we're going to show you what this is. But what someone has done, or I shouldn't say someone, but what people have done, we talked about it. The hard part is going to be able to find the area. When we're looking at this curve, we know we broke it apart in the last one like, oh, this is 68% and this is 16%, etc. But what happens when you have a value that doesn't fall exactly on a nice even thing? Like, what if I am minus 1.34 standard deviations away? So what we're going to be looking at is using something that's called that z-score. We're going to be taking some sort of chart, some data, and kind of turning in a number into a z-score. So let me back up and tell you how that works. And I'll use the example just to start out with, the example that they have on 78. The formula that we have for this is that if you want to calculate something's z-score, you have to take the value that you're looking at. It could be your height, your shoe size, your weight, whatever it is. The value of the individual value, we're going to subtract from it the mean, or mu, and we're going to divide that by the standard deviation. So before I can find a z-score, I already have to know the mean and the standard deviation. Well, we did that in the last chapter. You can find the mean and standard deviation of anything pretty easily. In this example, they're saying, and they're telling us that we want to find a person who is 60 inches tall. All right, and well, that's the one they use. I'll use a different one. I'll use mine. So, or someone who is 67 inches tall. 67 inches tall. All right. I apparently know that the mu is 64 inches and that the standard deviation is 2.7. So looking on my chart, that would mean this is 64 inches and this is 66.7 and this is 69.4. So I know I'm right here, just a little bit beyond one standard deviation. All right. If I wanted to know what percent of people are just a little bit or just less than 67 inches, all right, I already know, we talked about this before, that I could have used that chart, the one that I had. Let me jump back over here. I could go through and figure this out and say like, oh, I know all the way up to 1. 34 plus 34 plus 13.5. All these added together, I could figure that out at up to 1 standard deviation. Coincidentally, if you really are sharp, you would say, well, this is 50% plus 34, so I'm at about 84%. That's a pretty good approximation, but I'm just a little bit taller than that. Not by much, by 0.3 of an inch. So we would calculate a z-score. All right, and remember, to do that, I'm going to take this information and I'm simply going to plug it in a calculator. I'm going to say, well, 67 inches minus the average of 64 divided by 2.7. That's going to tell me my z-score. And so I'll take a moment just to do that. All right, I threw that together and I ended up with 1.111111, and it just keeps repeating. So I ended up with 1.111 repeating. All right, that tells me, since it's positive, it tells me that I'm greater than the average. If it would have been negative, it would have been I was down there. And look, it really means that I am not just 1 standard deviation, but 1.11. So that's what number, that's where this is. This is 1.11 standard deviation greater than. So I could have said like, oh, I went this way, 1.11 standard deviations. All right. So now, how do I find the area? If I want to find the people that are less than that, I'm talking about all the people starting way over here, going all of this information until I get up to right here. And remember, I have to find the area. And because it's this curve, it would normally require calculus. But no, we are going to be doing that with this z-score chart. Oh, and that's not the one that I had. Let's see, where do I have that z-score chart? I have it around here somewhere. All right, so here is a z-score chart, and what I'm looking for is a z-score of 1.11. All right, and that's a positive z-score. So most charts have negative and positive. This one, if I look online, and it's also, again, in the back of your book, here is 1.1. All right, but then I have to add on to that. This is 1.10. That's this number right here, because I looked down the score. This is 1.11 and 1.12. Well, the closest I'm going to get is that right there. All right, 86.65%. By looking at that chart, going to 1.1 and then looking at the chart saying 86.65%. That is the value of all of this, starting way over here. This is 86.65% of folks are less than 66.7, or excuse me, 67 inches. And I think in this case it was women, less than 67 inches tall. All right, so let's do that again. This time, though, when they describe something that it's a normal distribution, they will usually describe it like this. And they'll say, well, here's a normal distribution with a mean of mu and a standard deviation of sigma. So if I see something that says this, normal distribution of, let's say, 10.5, comma, 2. Maybe that's shoe sizes. Male shoe sizes, the average size is 10.5, standard deviation of 2. Remember, that means that my distribution, 10.5, first standard deviation is 12.5, second one, 14.5, and so on. All right, so what if I want to find all of the men that have a shoe size that is greater than, so let's say X is greater than 12. All right, I don't have an exact one. That's somewhere right in here. So I'm looking for all of this data that's over here. And it's important to note the way that they have this set up. You'll notice the greater than or equal to or greater than, they talk about this in what's called a cumulative proportion. There's nothing exactly at 12. All right, so it's going to be the same as saying greater than 12 is going to be saying greater than or equal to 12 when we're taking a look at that. So 12 is kind of included in both sides and not included in both sides. Kind of strange statement. But anyway, remember to do this, I'm going to do the z-score is equal to 12 minus 10.5 divided by the standard deviation. So I'm going to end up with 2.5 divided by 2. And then we're going to turn that into a decimal of 1. I guess I could have done that in my head. 1.25. All right. Now I'm going to go to that z chart again and look for z equals 1.25. So let's try to do it a little bit quicker this time. Here is z equals 1.2. So I'm looking in this row, and I'm going all the way over to where 1.25, and I've got 89.44%. Well, that's the amount of people that are less than, all right? So let's jump back over here. That's telling me that 89.44% of people are from here all the way up until this line. Well, simply 100 minus 89.44% is going to give you the value all the way back to that line, or whatever's left over. So in this case, I would have 10.56%. So looking at this, men with shoe sizes greater than 12 is really 10.56% have the shoe size that's going to be greater than 12. So hopefully that gives you the idea then, and some of the things that you'll be investigating in class is, well, how could I do something where I need to find on a normal distribution the group of people that is, let's say, greater than, I don't know, whatever it ends up being, like 11, the shoe size greater than 11, but less than 13. So again, the idea is going to be find the z-score here, find the z-score here, and then be able to find the difference between these two, because we're looking for what's in between them. All right, so that's what we are doing with the z-scores in that table. There's a couple good examples in your text for going through that, but that really is pretty much what we're doing in Chapter 3. We'll talk about finding other ways to use it. There's calculators, there's online calculators and whatnot to find those z-scores, so that it's not something that you memorize. And it also basically does the calculus of finding the area under a curve for you.